So hopefully we can have some discussion later on if we have time. Next, I want to invite José Eduardo Bertuzzo. He's the executive of the product technologies at the Eldorado Research Institute. And he graduated in the electrical engineering from the State University of Campinas in Brazil in 1983. And since then, he's been very heavily involved in R&D projects with years of international experience in various R&D laboratories in IBM and in Europe. He joined the Eldorado Institute in 2004 and was responsible for establishing the IC and hardware design area at Eldorado. Mr. Bertuzzo, we are pleased to have you at this discussion. You have 10 minutes. Thank you.
Okay, thank you. Could you guys hear me well? So
yes.
I would like to okay, thank you. First of all, good morning, good evening to everybody. I would like to thank you, all the organization, for this invitation. A pleasure to me to be here. So what I'm going to do is, in these 10 minutes, is try to talk a little bit what we do in R&D in this segment in Brazil. The idea is to be like the extract of what we do in Brazil, and again, later on, also propose 2 segments which we could do the collaboration, okay? Thank you so much. So, just a little bit introduction about Eldorado. We are a private institute. I think Secretary Henrique Miguel spoke a little bit about the informatics law, parties, and so on. So I would say that we are straight results from those policies here in Brazil. It's a 23 years old institute. We have sites from Manaus, Brasília, Campinas, and Porto Alegre. Just to give an idea, it's a 5-hour flight from Porto Alegre to Manaus. So we try to spread all over Brazil our operation. Okay, so we have around 1,060 people working today at Eldorado, and we run typically 200 projects each year for 80 different customers. Okay, just to give an idea of, and we cover, of course, microelectronics from design, packaging, but also we do a lot of work in the digital transformation and ICT information and communication areas as well. Just a brief summary what we do in terms of technology in this segment. We support, again, based on what Secretary Henrique Miguel, we have since 15, 20 years a policy to induce a new design house in Brazil. So we have one branch that support chip design. We go from front-end design, digital, analog, mixed signal, everything, up to the back-end, synthesis, layout, and routing. And we run projects from 180 nanometer up to the point of 5 nanometer that we are running right now this year, right? We're glad to say that we did already tape out with Celterra, but we work also with tape outs with different companies, mainly those that were in the list of Secretary, to provide support in this area, providing expertise, also providing access to the tools. Some of those companies were startup back in 12 years ago, so there is also a program to support them access to EDA tools to start their business in terms of chip design. The other branch is related to packaging. You know, I think Rogério Nunes from Absemi and also from the Smart, head of Smart Modular Technologies, you know, will I think go into more details later on. But there is a very important business in terms of packaging in Brazil. So again, the institute is a private, not-for-profit organization. 90% of our revenue comes from companies. So we keep, you know, what we do is really always related to the strategic roadmap provided by the companies. We try to be tied up with what the companies need in the future. So we also have them. A part of what we do is related to packaging design, from layout, signal integrity, routing, everything related to advanced package design. Also, we are moving the last 3-4 years in the heterogeneous packaging, heterogeneous integration. First with the photonics, we're designing modules especially for high-speed communication through fiber. We are actually designing chips and also the modules to reach 800 giga per fiber, right? And also to support the process, because again, we work in the intermediate tier also. We are not doing research. We go to applied research up to develop the product. So we have infrastructure that would provide testing and also design the testing software for chip design, right, for the chips, and also a prototyping through what we call a prototype lab for packaging as well. And through the qualification, we are full feature capability of the JEDEC qualification of modules. Here are some pictures of our packaging lab, which is a collaboration with the Smart Modular Technologies company. So we are able to do stacking, and maybe Gary Nunes later would give a little more details, and a little bit of the kind of equipment we have in our lab that allows to do in terms of advanced packaging. One thing that I would like to also to address here is, before the opportunities, is give a very brief idea about what we have in terms of microelectronics. We have around 50 research groups dedicated to the semiconductor. They are spread all over, main Brazilian universities. And PADIs had created and helped to create two technological institutes, what we call research technology organizations. One is Eldorado, the other is ITT Chip in the south of Brazil, that are dedicated to the top of integrated circuit design and advanced package, right? So it is something very important, because it was not so usual in Brazil in the past to have organization like this that is in the process of bridging the gap in terms of the technology evolution, bringing innovation to the products down the stream, right? So this is something that PADIs allow to happen in Brazil, and with support of the companies, which is very interesting approach. Another thing is Secretary told us about 500 designers, right? So in fact, we estimated that only 25-30% of the designs that were prepared by this extensive research groups really are working in Brazil. So matching this 500 will be like almost 2,000 people spread all over the world, working in the technology companies in the segment of the semiconductor. One side, we are sad because eventually we are not able to provide the opportunity to those people that get prepared inside our universities and our research centers. But on the other hand, we are happy because we are able, it's proof by that we're able to prepare people with the right skills and valuable skills to the industry. So we think this as an opportunity for us to increase our competitivity in terms of semiconductor industry, attracting and keeping the people here, providing them opportunities into design and into this industry. So by that, I would like to switch, and there is a very good coincidence in the areas that I'm bringing here, because one, of course, is the advanced packaging. Since we are really tied up with what the industry is doing in Brazil, and we have a consolidated industry in this back-end area, we foresee, a very good opportunity in terms of advanced packaging, heterogeneous integration, driving by integration, heterogeneous integration through the, 2.5D, 3D system in a packaging, all the technologies, multi-die packaging, interposers, embedded die, TSV, micro bumping, wafer-to-wafer bonding, even eventually hybrid bonding, and of course, chiplet approach, of course, something that's being discussed all over as a great technological opportunity. We foresee for the high-end kind of but we foresee the approach and the concept as also interesting. to apply in the system in a packaging kind of approach, where you can build up by building blocks some specific kind of application and in a specific kind of requirements that eventually we will have in Brazil that could have some matching in other countries around, and especially on automotive, for instance, where we foresee that by the ethanol business we have in Brazil, eventually we will not follow the full electrical car, but eventually a sort of a hybrid car. So that means that we will have to eventually, along with other countries that will have similar kind of a situation, develop some specific kind of technology. So this is kind of opportunity in terms of the market in which we could use the advanced packaging technology to fulfill the gap. The same applies for health, energy, smart cities, and agribusiness as well, which is a very important business, by the way, here in Brazil, and we need to keep up. And the way to keep up is to really put the technology in the front end of the agribusiness as well. The second we are considering as well is the wide bandgap semiconductor, specifically the silicon carbide. You know, we see application in solar inverters, automotive and mobility, especially in this situation that we will have a late adoption of electrification, you know, passing by eventually a hybrid or light hybrid, and of course, charging infrastructure, right? So there is a roadmap for silicon carbide. You know, we think that is getting a momentum because this 1200 volts kind of platform is catching up for charging, for, you know, automotive kind of application, and as well for photovoltaic converter. So that means that volumes are building up in around this kind of platform that could bring some opportunities. Just for here some markets for inverters, for instance, solar and also automotive inverters showing steady growing. You know, that I think is will be an opportunity some way, especially because as was mentioned before by colleague Dr. Lee, it is a technology. You know, the power MOSFET transistor doesn't require, you know, very low deep nodes to produce regular, and, you know, like 600 nanometer kind of technology could provide some with adaptations, a possibility to produce those modules, right? So, and again, as was already mentioned, Brazil just hit 30 gigawatt milestone. The interesting thing is that half of this was done in the last 18 months. That shows us a very good opportunity in terms of our market, because it's catching up fast. And another thing that is very interesting, around 70% is in this distributed generation, which brings a lot of challenge in terms of how you control the grid, right? And because this is moving so fast in Brazil, I think there is opportunity to increase local content in the inverters, and also deploy intelligence on those inverters in order to provide in the future better control of this grid. Because we see already in some places, even in Brazil, some blackouts created by the percentage of this kind of generation being too high, and any problem could be the cause of a blackout. So there's a challenge, technical challenge, and I think the answer will be providing and giving some intelligence in the edge, in the inverters, and which is, I think, is a good opportunity. And Brazil already has some players in this segment providing inverters. And again, as in Malaysia, most of what we do right now is integration, installation, and service. So there is here a good opportunity to increase the added value by doing the modules, by eventually going up to the point that we can design and produce silicon carbide power MOSFETs in the future. Right, gentlemen, that's all that I have. Thank you.